Yeah, so this is one thing I kind of mentioned in the previous lectures, right? The access grid and how, what this is. So this is the one that we have down at the OIT building, right? And I kind of got a few pictures of how the access grid teleconferencing system works. I mean, I couldn't find any video to show what it does, but essentially you have a bunch of people in different areas trying to do a conference where you need to have lots of these displays, lots of these projections from different sites, right? So the idea here is you have different projections, maybe one for human beings, one for the presentations, and so on. So you are essentially sitting in different rooms where you need this big display wall with all kind of projections, and you have teleconference, right? And people are sitting using the computers and stuff. This is from Argonne National Labs, and this is there are very few pictures of this thing, which is unfortunate because you would think that there are a lot of pictures of something which is meant for a high-end teleconferencing stuff. So this is from Jackson State. Again, you have like nice chairs and stuff. So essentially, you are trying to sit in auditorium kind of fashion and have lots of displays and have lots of displays which show different contents, different sites and different contents. And apparently, this is the Notre Dame Center for Research Computing's access grid. This is not the one at OIT. It looks pretty lame compared to the other ones, right? But that's all we have, right? So, but essentially, the idea here is we all sit here, and then you project it along the walls to have a conference.
So essentially, it's just instead of one monitor in the room, you have like 3 or 4. You
have lots. Yeah, not 3 or 4, like more like 20.
Oh, okay.
20.
It only shows like a couple of them.
Yeah, I mean, you could go to 20, but depends on how many sites join in, right?
Okay.
I mean, essentially, you have different feeds. So if somebody's making a presentation, you probably have PowerPoint on one and some video feeds on the other, right? So if you have like a 20 site, a 10 site interaction where each site has a video feed and screen feed and all those things, then you'll get 20 streams. I think you can scale to 20 streams. Essentially, so I don't think there's anything technically innovative that they do. It just brute force. You use internet these are usually between internet 2 sites. You have plenty of bandwidth, you have plenty of resources. Each one is an independent stream which is going through. It's not synchronized to anything as far as I know. So essentially you are broadcasting, like say the PowerPoint to all of them, audio to all of them, audio video to all of them, and so on, right? And the system has enough capacity to scale to 10 or 20, right? So yeah, again, I don't think it's meant to be innovative. It's meant to work just now. I mean, right now. And unfortunately, we can't demo it because we need a site on the other end to actually show it. And this is the other thing I was mentioning in class, right? You can buy these things. I usually see them on the airlines. The mall, the brochure that they have on the aircraft. I think this one is like $800 or $900, right? There are some which are smaller than this one because this one looks kind of intrusive, right? I think you can actually have it where it looks sort of bigger than your eyeglasses. Not like this one, because I think if I walk around like this, you probably think that I'm blind or something, right? I'm probably blind because I can't see the external world through this stuff, right? And again, you have to block out all the lights so you can actually get a good view. And it's supposed to be high enough resolution that it looks like you're seeing a 70-inch HD monitor from blah 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 kind of things. Again, it's the my impression of these things are good, but you don't watch them for a while, right? Because if it really worked, I would really love one of these things, right? Because especially when you're flying or something, all you need is then your screen is basically like this. You can keep your laptop somewhere, have your screen, and then start working or something, right? Or watch movie or something, right? But apparently the technology is not there, and apparently it will never be there because of certain ways I work. And I'm not an expert on how the eyes work. So as promised, the Hydra folks, he sent me one video. They got he encoded and sent it to us. So let's see if we can see the video.
At the fall 2004 Internet 2 member meeting at the University of Austin in Texas. In a very exclusive experiment, the Miro String Quartet performed live in front of an audience at one of the venues at the university. The stage was instrumented with multiple high-definition cameras and many different microphones. We then captured the environment of that venue, and we transmitted 4 high-definition video streams across 10.2 channels of sound from the first venue to the second location, where it was rendered for the second audience. The quartet was performing their concert, and the audience was swapping locations during the intermission.
We're glad you could come for what's going to be, in my view, an absolutely sensational evening, the likes of which you've never seen before. You are members of the Orange Group, and I am the Master of Ceremonies for the Orange Group. The first half of the concert, the Orange Group will witness orally and visually in this room, and I'm here to tell you that the Miro Quartet will really be on stage. Then I will lead you all during intermission to the McCullough Theater, which is about 150 yards in that direction, and the building immediately adjacent.
It's like a 2-minute, 3-minute segment, so you can see that.
There's another audience over in McCullough right now. The Master of Ceremonies for the Green Group is Vice President Updegrove. So you'll see Updegrove coming in this direction while we're going in that direction. But once we all get into our new seats, the second half of the concert will begin, which you will experience virtually. This has huge implications for the future of touring of musical and artistic ensembles of all kinds, as you can easily imagine. Which is to say, it's one thing to play a concert in Seattle, but if for 2/3 of the price you can play a virtual concert in Seattle, you may as well stay here in Austin and enjoy good restaurants that we have here.
Again, I don't think it's the case where each one of them is in a different site. I think they're all in one site for practical reasons, right? But the real thing that they wanted to do was to have each one from a different site and have a super virtual concert. But I think each one of them is a separate stream, not coordinated necessarily.
So they're not doing 3D or anything. They're just streaming the video.
Yeah.
Was the next step to have different people in different places?
Yep. Different set of people in different places and have an actual symphony, and that would be the real hard part. Right, where they can. So right now, the performers can coordinate amongst themselves by looking over their shoulder, but then it'll be off.
Wasn't there a pretty sizable delay, time lag between, like, going from East Coast to West Coast per se over the internet?
So there is, and let's get to that in the context of this one, right? The key is, if you remember the paper, they were seeing like 300, 400 millisecond delay for capturing video from the camera to their system, right? And Coliseum also sees some of those. So you're seeing 300 millisecond delay from the components that you have no control over. And network-wise, you usually see like 30 or 40 milliseconds cross-country. So it's only 1/10 of the overhead you're going to see anyway, right? So yes, you're going to have the 30 millisecond, which you can't control because that depends on the speed of the light. But right now you're seeing another 300, 400 millisecond on the other stuff, right? So it shouldn't matter. I mean, you would like to make it smaller, but there are other things you need to worry about first, right?
The video we just watched, the video itself, there was nothing to it, right? That's just what they're hoping they can do?
Oh no, this is actually they did, right? They
just had video cameras streaming video to another room. That's what they did.
Not another room, right? It's supposed to be from Seattle. They had the meeting at Austin.
He specifically said it was 150 yards away.
Oh, he did? Okay.
Yeah.
And the four of them are right next to each other, right?
Yeah, that they haven't done yet. Oh, but you have to remember, like, getting...
I'm sorry, maybe I'm missing something.
The hard part about it was synchronizing since they were each capturing on 4 different microphones, synchronizing those four
yes.
while streaming.
Yeah.
Okay.
So, I mean, the ultimate goal is a lifelong effort, right? Because ultimate goal to synchronize across multiple sites is pretty hard. I mean, like, as researchers, that's ultimate goal, but to reach there, it's not trivial, right?
Yeah, I was just very confused.
Oh, you got it. That's how simple it was.
Okay.
Yeah, so conceptually, so what you would expect is it should be so simple that you should just be able to do it, right? You shouldn't have to think about any of those stuff. And at least their research and all the others show is it's not as trivial, right? It's not as trivial to have a camera in one room. So it's not actually sending it as a video, right? Right now, if you take it from the other room as a video signal and then show it on a TV monitor here, that's trivial, right? But it still goes through the system. Remember the paper from yesterday, right? It converts it into digital, sends it across as digital, and then takes it back, right? So yes, you don't have the delay component inside, and that's what I was telling him, that the paper was talking about from the camera through the system was taking 300, 400 millisecond, right? So network itself would probably be like 30 or 40 millisecond. The other components are the harder part, and most of you who do research would know how difficult it is to actually coordinate with another site and get these things going, right? Within a single room itself is pretty hard. So, oh, he's online.
He went offline.
I know. What happened?
Conventional telephones and video conferencing often leave people so unsatisfied that they travel to meet face-to-face. Coliseum is a working immersive video conferencing system that aims to bring the realism of face-to-face meetings to remote communication. Multiple geographically dispersed Coliseum users each use a standard desktop PC into which we've integrated 5 small video cameras. In real time, 3D models of the users are generated, assembled into a shared virtual environment, and rendered and textured to unique viewpoints for each user. This allows important interactions like eye contact to be conveyed correctly. The result is similar to earlier virtual world systems, except the avatars look like the actual participants. Every user has a location in the virtual environment and sees a unique view that is appropriate for their location. Users are free to move in the environment, and the views they see are updated accordingly. New view synthesis is a key component of Coliseum and is used to generate arbitrary views of users. To generate new views, the user is first segmented from the background in each camera frame. The segmented portion is projected into 3D and the resulting frusta are intersected.
This provides crude geometric models for the users. The new views of users are created by rendering and texture mapping these models. We use MIT's image-based visual hull algorithm that performs these steps at video rates. The inaccuracy of the visual hull models does cause some noticeable artifacts. We've developed a new algorithm, the image-based photo hull algorithm, that uses color information in the camera images to improve the visual hull geometry and reduce these artifacts. Textures can be badly misregistered when mapped to the inaccurate visual hulls, but look much improved when mapped to the photo hulls. The photo hull also usually eliminates the background pixels that often appear around the edge of the visual hull when it's texture mapped. Motion parallax is used to give users the perception of depth. Specifically, a participant's head position is tracked and their display is re-rendered to account for their movement. We exploited the multiple Coliseum cameras to implement a head tracking algorithm that's robust yet reasonably fast. Though initially tailored as a video conferencing replacement, Coliseum is also applicable for uses like distant learning, entertainment, and games. It is a working and usable multi-way realization of immersive video conferencing.
Okay.
Is that part of DreamWorks?
No, they used that scene, I think, that last scene.
Oh, okay.
They used the environment.
Yeah, so Chris volunteered to tell us about the...
Well, I wasn't sure if everyone understood how the visual hull part works. It's kind of interesting. How many people have ever played Wolfenstein 3D or the original Doom, one of those guys? How many people think that they were actually playing a 3D game? Good, all right. Because you weren't really. They essentially had little planes floating around and they textured the planes. Visual hulls are essentially working off of the same concept, that you can have areas that are relatively flat, but if you texture them, they'll look approximately right. So the idea is if you're trying to render the sphere in the middle and you've got cameras all the way around it, you're going to get the sphere and then the background. Remember they talked about segmenting the background a minute ago. Then what you do is you project this background onto the plane, and the actual geometry for this scene that I've got set up with each little camera around would actually be this octagonal structure. Or I guess it's hexagonal. No? Octagonal. And the idea is you would then take what this camera sees here and you would map it onto this little part right here. And in doing so, your geometry is pretty coarse, but it looks fine. I mean, they look like actual people is the essential idea. Anybody got any questions on how they do that? No?
So how computer intensive the whole thing is?
Well, there's a whole bunch of different ways to do this. I'm actually surprised. I looked up, it's been a while since I've looked at visual hulls, so I went and looked up the IBM paper. There's actually a better way to do it using graphics cards, which is very cool because it leaves the CPU not really busy because it's all calculated on board. They're calculating the actual 3D hull. So they go through and actually make this 3D object and texture everything onto it. When you do that, it can be fairly intensive. And they actually talked in their paper about needing to speed it up and wanting to improve the look and a few other little things. Because the MIT guys were actually much more focused on the geometrical aspects than the visual rendering aspects. There's another paper out that I think is actually much better for this application, although it does mean that you would need one graphics card for each user. Right? So each station would have to have a graphics card for.
But these are commodity graphics cards.
Yeah, commodity graphics cards.
Okay.
You can buy them for $100. You know, they're not very expensive. And what it does is, essentially, you know, you can think of all these things as a plane, right? And it actually renders each plane and uses the alpha channel to blank out the background. So graphics cards have this concept of an alpha channel when they texture stuff. And an alpha channel basically says, don't actually render me, right? It's like a little pixel standing here saying, I'm clear, you can see through me. So what they kind of do is they actually register the whole scene, and if you didn't have an alpha channel, it would look like all these weird things just kind of intersecting in really weird ways. But because of the alpha channel, it actually will render the exact hull correctly. It isn't giving me the geometry though. This is important to realize, right? It doesn't give you the geometry, it gives you the rendered geometry. But it gives you really good looking, perfect rendered geometry. And it means that it'll scale perfectly as long as you keep adding graphics cards.
Yeah, I think adding graphics card, so their model of what they want to do is like a corporate user, right? And they talk about a really souped up desktop, which is not a big deal because this is for corporate setup, and the cameras are expensive but not that expensive, right?
You don't have to use expensive cameras. I don't know why you would need to. You can
they just use webcams, right? Like on the rig they built, right? There are 5, 1, 2, and third, and then like there's a fourth one here, fifth one here. It's just webcams, right?
Yeah.
So.
You have a question?
Yeah. You were saying how for that other way you need like a graphic card for each person.
Yes.
At each station.
Well, actually, this is something Dr. Chan and I were talking about a while ago. What you would want to do is stream the resulting rendered video.
Right. That's what I was going to ask, if that would be better to just like.
So you would have each station. So let's say your computer is rendering your view for everyone,
right,
and then just sends what the view would be to everyone.
Right. Okay.
The reason you would want to do it that way is otherwise for each camera you have to stream almost the whole camera view to each station. So there's a lot of data going into this calculation and not much coming out. So I don't think you would want to, the rendering would be done where the cameras are and then you'd stream the result to everybody.
So yeah, that's the discussion we were having, because my impression was you send the 3D stuff to the renderer, which is on the receiving side.
Yeah, I was looking at the papers. I'm still not convinced which they do, because they're using MPEG, and they talk about using MPEG. So maybe they're. Does MPEG actually do 3D geometry?
Now that I'm.
But the way that he talked about it, they say that if you shift your head, you see a different view?
Certainly, but you could easily be sending that information to the other computer, which shifts your view for you. I mean, there's no reason you... there would be a larger latency when you move, right, but they actually had a pretty big latency.
But then you couldn't just render it and then stream it to everyone, because now if I shift my head...
You couldn't stream the same copy to everyone, that's correct.
Yeah.
Yes. But right now, you can't... Most networks won't really support you doing that anyways.
Support what?
Well, you don't really support multicasting if you're going to go long distances.
Yeah, I mean,
this
is
you
corporate.
actually have to send a new copy to everyone anyway.
No, they're talking about corporate setup, right? So multicast, whatever you want, you got it, right?
So, but no, I mean, there's different ways to do this. I'm not sure how they're doing it. Because they're not using this graphics card stuff. They're using a different method.
But like even with the video, they don't actually exactly say who renders or whatever, right? They just say it's rendered and sent, right? And
they've got this crazy diagram where MPEG seems to be what's connecting you over the internet, which is why I don't see how they could be sending
the model.
I don't know. The paper isn't clear to me. I'd have to read it a lot closer, and maybe I'd know.
Yeah, I think the project is over, right, within HP. So I couldn't find so much, but I can. So my contact is the woman in this picture, right? Nina Bhatti. She's the one who's the systems aspect of this one. So I can ask her what they were actually trying to do, right? So, but at least even if they don't do it, it'd be nice if you can send the 3D something and then you render it the way.
Yeah.
So when you see,
it just depends how you want to do it.
When they see the user walking around, right?
And you could do that with either approach.
Okay.
You'd have a higher, if you were to use the graphics cards, you'd have a higher latency. The other thing is though, Will, if you have multicast, then you could just stream all the cameras to everybody for the same cost. You could stream the raw data to everyone, and everyone could put it together on their end.
All the 5 cameras?
Yeah, why not? If
That's a lot of processing though, if you have more than like 2 people. because then you as a receiver would have to render everything.
Which is why I wouldn't do it that way. I would personally re-render each person's thing locally and then ship it out. It's just where you want to put your bandwidth. You can calculate the exact geometry. I mean, clearly they're at some point they're doing it. I'm not clear if that's the data that they're sharing or not.
So this is the one you're talking about that TV should do that?
Yes.
Okay.
Yeah. Whatever the paper we read last week, where I said why aren't they doing visual hulls, this is what I was talking about.
Okay.
See, what the people last week were doing wasn't this. They're calculating points in 3D and have colors for those points. But that tends to not look as good, and it actually is usually more computationally intensive. It's a more well understood process, but it's more computationally intensive.
Yeah, so I was talking to her last night, and I mentioned that some of the image processing folks said they could do it differently, and her point was some of the algorithms they looked at, they could do 1 frame per day kind of stuff if they did something, right?
No.
So I'm not sure what she's talking about, but hopefully, because I have no background in image processing, right? So this would be interesting.
But this is a quick and dirty way. There's a lot of people who talk about doing 3D TV stuff with this type of an approach.
But the quality sounds fairly poor, right? The people who are moving around and stuff.
The actual people on the screen looked a lot better than her people did to me.
Who?
The video from last week.
Oh, okay.
I think the people this week looked infinitely better than maybe.
Yeah, they just didn't have all the holes in them.
Yeah, they didn't have any holes in them. They don't, they're
You mean like last week, meaning like on Tuesday?
Yes, I'm sorry, last class.
The TV one, the dancer one.
Yeah.
Okay.
Yeah, I think these people, I mean, what do you guys think? I mean, this is a visual question. I'm not sure you can definitively say one is better than the other, but I think that this
I mean, that's an excellent question to ask her, right? Because
smudges are better than holes.
That's what I would say. Yeah.
Well, I mean, when you're imaging, like when you're looking at a smudge, there's not too much of a difference, and your brain can just make the adjustment of that's a smudge. But when you have a big freaking hole there, it's like
Yeah.
No, but I don't remember exactly what she said, but one of the things she said was dancers like certain things and not. I mean, they were looking for. I don't know the exact details, right? So it's something we should ask her, but they didn't mind certain aspects, but they wanted to see something else, and I forget what these two are, right? Because they were not trying to look at the picture to make it look good, right? They want to like dance with each other and see. They didn't mind the holes, but they wanted to know be precise.
Image, how can you really?
So
we'll have to ask her. Maybe they have a good reason, although I don't.
But she said the dancers were fine. They just started to dance and they were fine, except for the person in the back who didn't look like a dancer, who was just like prancing around in the middle, right? But they seem to catch on fine. Right?
But the other thing is, this approach should actually be more computationally friendly
than the other one.
As far as transmission requirements go, it's going to depend on a whole lot of stuff. I mean, are you transmitting the data? Are you transmitting the render data? I mean, transmission is kind of...
In another sense, like this is a lot less fidelity than what TV would want, right? TV would want like a... if you want to approximate a mirror, right, usually the dance studios you have the mirror for the whole wall, right? Whereas this one is more of a desktop. I mean, this is like a normal monitor, right? So you're only seeing like this small person, right?
Well, yeah, but it would scale up just fine. The other thing to remember is these guys are using 5 cameras. They were using like 20 cameras. I mean, this approach is going to get better the more cameras you give it. So I mean, it's
so if you go to high definition, rather they use VGA cameras, right?
Yeah, they're using for this example, they're using relatively cheap cameras.
Yes. But so if you scale the quality of the cameras, would it make any difference what algorithm you use? You still prefer this one rather than the other one?
Yeah, absolutely. Because this one is going to be able to take, in some ways, better advantage of that. Because with this one, remember, like I said with the Doom guys, there's a lot of flat areas in this approach. And so the texture of that area is absolutely critical. you have a bad texture there, you know, you can tell. You know, for example, I don't know how many people have played the Xbox 360, but the cool thing is you can play the old games. You can plug in like Halo 1 and Halo 2, and there's a lot of walls and a lot of objects that looked fine under the old resolution. But when you try and upgrade the resolution, it looks horrible because you can see the blockiness and the texturing. What this is giving you, a higher resolution camera, is giving you higher resolution texturing. So it's going to upgrade the texturing on these models. So literally just upgrading the camera, same number of cameras, but you go to HD instead of the other ones, it should be substantially better. You're going to be able to tell a huge difference.
Visually and computationally.
Computationally...
No, I'm saying computationally it'll be proportionately worse. You'll need more CPU.
I don't think you would need proportionally more CPU.
Okay.
You would need more CPU, but really the only thing, for their approach, as they did it with the image-based visual hulls, the number of pixels in the outline of the hull is what's going to be your geometric computational threshold. So as you increase the number of pixels on the image, you are going to get more pixels on the outline. But remember, if you go back and you assume it's let's assume for a minute that it's circular. You know, the outline of a circle is 2 pi r, but the interior is pi r squared. So it's a linear factor versus a non-linear factor, right? So the calculation is proportional to the number of pixels in the outline, which is going to be a linear increase. So you can actually, it's going to be less, it's going to scale better.
I had a question about this. Why didn't they just put something on the person's head to tell them where the person was in relation to the ship to the cameras? And then you just have the person spin around slowly in the chair and you render the whole freaking head. And then all you need to send, you could just, all you need to track is where the eyes are looking and then where the head is pointing with that little...
Because they wouldn't be able to talk.
Well, then just, you know, look at the mouth a little bit. But I mean, it's
like... You could get into all that. I'm just saying, if all you do is...
So remember...
The person's not going to move. Their face is...
See, remember one thing. Their competition is the Cisco one, even though I have no idea how that works, right? The competition to Cisco one where they want it to be some product that HP would sell for their corporate customers, right? So there are probably limitations on putting stuff on people's head.
On their head.
So the nice no. So the nice thing is like this one kind of like, you know, like you can kind of move the arm inside the monitor and it looks fairly not too intrusive. I mean, it still kind of sticks out, but when you have the conversation kind of like wraps around you. But in a cubicle, that's more preferable than putting stuff in the head, maybe. Right? I don't know about those, but again, all these are driven by the.
Well, I mean, you could alternatively say, because eye tracking programs are pretty good, from my knowledge, you could just say, okay, where are the eyes, and you know, keep improving the image that you already have, instead of like recalculating all this stuff every single time.
Well, what you're describing is actually not a bad long-term way to do it. And that actually would fit into MPEG-4, which is having a face model that you can animate, and then just animating the face model with the talking.
Yeah.
It's also a much more complicated approach.
Oh yeah.
I mean, it's, you know, the concept of being able to come up with a model for a given person's face is not straightforward. And it's not going to look as good, modern approaches wouldn't look as good as this would either.
So okay, let me get that straight. So you're saying that if I have a model of my head, then animate it on the other end.
That's what he's saying you should do. Yeah. He's saying you should build a model of the person's face, then you never have to transmit the model once it's there. And you just animate
send a DVD of my model, yeah.
It doesn't have to be a DVD, you could probably transmit it.
Okay.
You know, but it'd take 10 seconds or something at the beginning of the video. And then you've got a model and you animate the person talking. You could do that. In fact, MPEG-4, I believe, has the ability within it for this concept of a, like within the specs, which are huge.
Yeah, remember, MPEG does, it does certain transformations, not the kind of transformation you're talking about, right?
I thought they actually had.
MPEG-4 can do transformations like these, right? Moving your hand and like the linear transformations.
Okay.
They do, right? So you can actually send a stick object and like kind of, if I move my hand like this, that's easy, right? Because it's basically translations on one axis. But the mouth moving, I don't think it can do. I don't think the specs.
I thought someone had written into the specs actually the concept of 3D facial geometry and how to model it. I don't think anybody implements it.
No. Okay, I never seen anyone talk about the face, because face moves in a fairly complex way, right? Yeah. Like, which you guys probably know the biometric aspect of it, right? Hands moving is fairly trivial, even though when a hand moves, either way, you still have to model something, right? I mean, it's not just like when a hand moves up, it moves like a straight stick, right? But I've seen systems which talk about stick objects and how to animate on the other end. But speaking, so the one thing I like to say is this is all brand new, right? This is happening right now. So if you come up with the idea of why people don't do that, hey, that's maybe a good thing to try. I mean, this happened. This was published in 2003. I think they wrapped up the project maybe 2000. I think even when I talked to 2004, 2005, they were still working on this one. TV, they're still working on it. The Hydra project, they stopped because of the reasons I was mentioning, that there's very few people who are willing to fund that kind of a research, right? So one of the so if you really want to test that one, and one of the vision was to have one player in Miami, one player in New York, and one player in San Francisco, and having a symphony watching in Seattle, right? The cost of doing that is tremendous, right? Not just in terms of, so being able to stream all the stuff, being able to, most of you are aware, right? Like if somebody says, I want to see how it should be in Miami, we have to ship you guys, right? Because all these are done by grad students, so we have to ship grad students off to, one of them to Miami, one of them to wherever, and you have to pay for keeping them there and all those things. And so there's not enough. And all of these require money which somebody has to come up with somewhere. And then
wait, to do that kind of stuff? Why can't you just send, just have a router in Florida and have people in 4 different rooms and send your data through the router and back?
Oh, that they can do. So if you look at it from the research stepwise point, right? So right now they're saying we'll just have both of you in the same school and then try to stream it. Next, you can emulate a network to go further out, right? But if they did that, right, we still complain, right? We'll really like to see at the end, like them actually being there, right? We all know that simulation is only, it only takes you so far, but you really want to see how it will look like at the end. But anyway, so they couldn't get too much funding on that one, and Roger is leaving to go to National University of Singapore because of financial hardship and stuff. So I don't think that project is going too far on what they're doing. So this is wrapped up. So, but if Cisco gets into the market and tries to do something like this, right? A lot of people, it's much easier to deal with it if you're doing access grid kind of stuff, because that's the brute force approach. But companies would really like something like this. You're sitting in a cubicle and you're having a virtual conference and you save on travel budget. It's a really awesome product, right? So in that kind of systems, they wrapped up, and I don't know if HP is actually selling this as a product, but if Cisco has to do this, then I'm sure HP would want to make it into a product. So these are the different data points which are all happening right now. So if you don't like them, we can at least ask her, because she works in this area, so she probably I don't know why it goes into this mode where okay. So in terms of this project, they were again talking about teleimmersive video conferencing system, right? Sort of like the UNC work, except their goals are not as grand as the UNC one. I mean, this is for a cubicle worker, So they had to spend a lot of time and energy to build that rig, right? And she was saying it's not as trivial as you think, because it has to be industrial strength plastic, so they had to have the HP engineers design that thing, right? To me, it looked like a stupid plastic thing, but apparently it's not as trivial, right? Which of course the university systems don't have to worry about, because we don't have to worry about the cost of manufacturing this, because they have to make a pitch to the company that this is something that you can sell for a few $100s kind of thing. I think, if I remember correctly, one of the things she shared was when they started this, there are a lot of desktop monitors, which is pretty good because there's a heavy thing sitting in a desk, so you won't mind this. But when you go to LCD, they have to figure out how to, compared to the LCD screen, this will look bulky, and you have to figure out how to make that work. So their model is you have very powerful desktops, whatever the money can get you, and essentially have VGA webcams hooked up on one firewire cable to keep the cost down. And you basically pull this thing out to a teleconference and then kind of push the arm inside. So this is the part that I thought, like, from talking to her, that they actually generate the models and transmit it, but it's not clear precisely where the rendering happens, where the 3D rendering happens, right? Regardless, if they don't do it one way, it will be nice to send the 3D representation off, or send the 3D representation once and then do the animation, right? And they mentioned that head tracking proved to be too intensive that they don't do that, right? But some of the pictures, they look like they do some head tracking, and some of the demo, they actually the guys actually moving the mouse to change the view, right? If they couldn't do it because it's too expensive computationally, that ought to be fixed soon, because if you have like a quad core or one of the processors, they should be able to do that, and if they can use the video card, that should be solvable too. I have no reason, I don't know why they don't try video cards to do this. And the interesting part to me is this component, right? So one of the things that you mentioned is how would the delay look when you're cross country and stuff. Since it takes that much time to do this processing, which seems better than the previous work. This is the end-to-end delay that they see from the camera to the other end. If it's 300 millisecond, then in their case they only see 3 milliseconds because it's a gigabit switch right across the hall. But end-to-end, across the continent, it's 30-40 milliseconds. So you probably are not going to be noticing the network effect, right? So one of the things that I would like to do, so next Tuesday, I'm again going to be out of town for OSDI, right? But I'd like to do a video lecture from Seattle, because one of the things we wanted to try was have a video conference with folks in Greece, but I can never get Manelos online, right? So I would like to see how a video conference, video lecture would look. So essentially, you would have, we need somebody who can, point the camera at you guys and have a microphone, and I'll be in Seattle, and we can see how far we can go, right? No fancy stuff, like the iChat video or something. So do you guys think it'll work?
If you could get 2 projectors going, like one with the PowerPoint and then one with your video, I think it would be a lot. I think it'd be better quality. Just because if you had both on one, it'd be hard to kind of read your slideshow.
It'll work. It'll work. The firewall.
Yeah. And firewall was great.
Oh, don't get me started on the.
You notice the network's gotten really slow lately.
Anyway, so let's finish this thing before we go there, right? So some of this paper talks about was the image processing aspects of it, and Chris gave us a good overview of the stuff. And there are a lot of stuff that she said, like, which she didn't know before, like, correcting the lens distortion is a big factor, because these are not top of the line cameras, so the lenses, the pictures are not exactly the way they should be, and you got to go through a calibration. And the color calibration, I think they actually spent like a couple of months to get all the cameras to look the same color, right? And the way they take the background is, if there's no human being, whatever it sees is the background, right? So I didn't know what happens if somebody walked into the room. I guess they'll also be seen on the other side, right?
It depends how you do it. I think they're doing background subtraction. So essentially, before you enter the scene, they take a picture, they know what the background is, and then anything that's different from that background color must be part of the format.
Yes.
So if someone else came in, yes, they would be added in, but the visual halt algorithm could go nuts with that.
Well, actually, the worst part is not somebody comes in. Like if you look at one of the pictures, I forget where it is. How many of you been to HP labs? It's a one big room with lots of cubicles, right? And for some reason they decided they think it's a cool thing that only Hewlett, those two guys had an office. Everybody else has a cubicle, right? Which I think is a horrible idea because cubicles are good for something, but not for everything. So they have like really tall cubicles, right? So if you look at one of the pictures, you actually see like out through the cubicle of your cubicle out into the hallway, right? I think is this picture one of the pictures in the on the paper, right? Let me see. Yeah, this one, right? Where he's sitting, right? You can see right through. That's out of his cubicle out in the hallway. So if anyone walks in that one, you pick it up, right? And so yeah,
whether or not, if he was far enough away, whether or not it would really be rendered, I don't know. It depends on the details of your algorithm.
Okay.
Because you should have a clipping plane if you're doing it well, and stuff that far away shouldn't
show up, right? Because otherwise, I guess you'll go crazy, right? So one of the things that they were very happy is the ability to project yourself in a different environment than where you are. And their point is, yes, the company thinks that cubicles are nice, but most of them would love to be in like some of the scenes that they talked about, and you can meet their kind of stuff, right? And yeah, the color calibration turned out to be very hard, and the reconstruction and the motion parallax. So when I talked to them one-on-one, it seems like what they would like to do is, if there's two people sitting here in a conference, then I see all these people, but if I look around, I should be able to see this person only the side, right?
So I'm just surprised that they think that the lens and color calibration are big deals. Are these people that don't have a lot of visual experience?
I have no. So I only know one person. So do you recognize any of the other people? I thought like the Donald guy. His webpage looks like he's an image processing person.
Okay.
But do you people on the image processing side, do you recognize any of the names? So somebody has an MIT connection, right? So they
use the MIT guys to help them.
I know, but
I don't know how much of help they were.
No. So that would only happen if either MIT guys are so nice that they help every human being out there, or one of them graduated from MIT, right? And I bet this is the second case, right? Because MIT guys are probably doing something on their own, so they don't run
MIT money for help.
No, but MIT is big enough that they're not going to be a slave labor for helping you with the product, right? So it's highly likely that somebody from MIT graduated and formed went to this group, right? So they bring you guys know, right? Like, how many of your code can be useful by somebody else if you ship the code, right? Most of the code that I write is not industrial strength that you can just send it off to a lab and then I don't hear about it, they walk off of it, right? Most likely there's a iterative loop, and so I don't know who is from the MIT group. So I figured one of you may know, right? So all these groups should have some image processing person, because HP Labs is not devoid of image processing, right? At least for the printer division, which is their bread and butter forever, right? Image processing is the one which brings them all the money, right? Most of the money. So, and the same for Clara too. Now, same for all these groups too. These are not from schools which are so small that there's only one person who's doing systems and image processing and construction and calibration, all those things, right? So I was kind of surprised about that part too, because I would think that the printer division in HP may know something about color calibration.
Well, I suspect
the
it's
scanner
really more
division.
about lighting than color calibration is really the problem. But the lens distortion is very easy to fix. I'm very surprised that they think that was a big problem. It's something you have to do. I'm not questioning whether or not you have to do it.
But you think the color calibration is easy or hard?
I think it depends. If you're actually saying raw color calibration, then no, I don't think it's that hard. But I think what they're trying to deal with was light calibration as well.
What do you mean light calibration?
You want to, lighting really affects how things work.
Mm-hmm.
I think what they were really trying to do is make sure that, with this lighting versus lower level lighting or higher level lighting, everyone would look the same.
My impression was she was trying to calibrate across the 5 cameras to make them all see the same color.
Oh, well, see,
or the same person.
I'm surprised that's a challenging task.
Because like the color chart they had was to calibrate across all the people, right?
Then that shouldn't be.
And they didn't have to worry about people being in the dark because most offices are well lit.
Yeah.
I mean, you can assume this level of lighting, right? But the point that I thought she was worried about was if you have a rig here, each camera should see the same.
If that's what she's trying to do, then I'm surprised.
And if you see one of the pictures they have, right, from the paper, they had this like this one, right? The color calibration chart.
Yeah.
They were trying to calibrate all the 5 cameras to see the same color, right?
I'm just surprised that would be a problem for them.
Which I'm surprised that you'll be surprised what they do, because I would guess that at least the scanner folks in HP should know something about calibration, right?
Yeah.
So unfortunately, Nina is not here, but so anyway, so they may thought these were issues, but in general, if you wanted to build one of these systems, there are a whole bunch of these other concerns that, so you're essentially drawing the folks from image processing, some from systems, some from networking and what have you to build these systems, right? And her point was a lot of the things that you think would be trivial are not that trivial, because you have to worry about the kind of systems, the kind of equipment that you have, right? So if you're talking about a HD camera, many of the lens distortion may not be a factor, but these cheap ones, they are. But at least she said one of the things they noticed was if it's not very well built, if it's like kind of wobbly, then the whole algorithm was going nuts, right? So you wanted something which is sturdy enough. And they also went off and built a software framework to add cameras, write the code, debugging, and developed a middleware, right? And part of the reason might be that there are folks who wanted to build a middleware, so that they just said, oh yeah, let's use this as a reason to build our middleware. But there's also a big software component of how do you build these components, how do you make this into a modular framework, and the paper talks about they using the Microsoft API to link into these things, right? Which in some sense is not nice. It's not a cool area of research that you would like to get into, but somebody has to do it to make these things happen. So especially if you want to go from 2 users to 20 users, how do you coordinate these things to make the whole process work, right? So hopefully this will give you a flavor. Again, I think we went on a very high level because the challenges, and Clara said she'll try to give a sense of what are the problems involved from her viewpoint. Hopefully, by going through these different papers, you get a sense of what are the design choices people are working on, and how to get these teleconferencing systems, right? There's a lot of interest in getting these things going, especially because people don't want to travel. And so that's one of the reasons why I wanted to do this. So do I have a volunteer who would set up these things? And usually I pick William, but is there someone else? What?
I can't be here. I was going to tell you about it later. But
Okay. So where are you going to be?
There's a luncheon for the
Oh. I thought you'll be in another town. So we're also saying, okay, let's have a.
Just in a different room.
I would help if someone else wanted.
Okay. So do you have another?
I don't have class before, so I can come earlier.
I think there's a class before here. So, the coordination is not. I mean, I don't think so. Yeah, I think I agree that there should be two projectors, right? There's one projector for hooking up the video camera part, and one for the PowerPoint slide, right? So, do you have another one too, or do I ask you?
Yeah.
So you and Nathan can. So I'll send the PowerPoint where somebody has to probably do the. I don't think I can stream the PowerPoint stream, right? So just send the PowerPoint so you can change the stuff, and somebody can look at, So I'll have the camera facing you guys, and I have a camera facing myself. Yes.
What would you use to stream the video, your video?
iChat.
Last night I had a video conference with a friend of mine back in South America. Granted, it was 3 a.m., so the network was pretty light. It was pretty good. It was just using Skype, and Skype was doing a pretty good job.
Yes, I mean, again, this is not rocket science, right? I mean, this ought to be something that we've been doing it for a while. I'm just going to use a webcam. This is not a research thing. We just want to see how it actually looks like, right? And again, this is going to be in the middle of the day, even for West Coast, right? Because 9:30 they should all be in work, right? It always feels like West Coast kind of wakes up later. I don't know how many of you noticed it, but West Coast, like if you go to HP Labs and you say, I'm going to come in at 9:30, they're going to be like, oh, that early, right? But if you go to IBM lab and you say, I'm going to come at 9:30, they're like, oh, that's late, because they seem to start at 8 o'clock and the West Coast seems to start at 9:30, right? But 9:30 is still late enough, right? Plus, I have absolutely no control. I have absolutely no idea how the hotel wireless or wired, whatever is supposed to be, right? They said it'll be good, but I have no control over that. I'm not doing this from UW, which is probably University of Washington, where I can guarantee anything, right? So it may turn out that the network is so bad that we may have to go to just audio or something, right? So we've done this, like, one of the meetings we had where folks are calling from Singapore, and on good days everything works fine. On bad days we may kind of struggle a little bit, right? I was going to try to have a HD camera and try to stream video, but I'm sure that the hotel network would croak for HD stuff, right? So yeah, after the lecture, we're kind of moving on to the next topic, which is the video sensor, which is what we're going to look at for the next lecture. And so a lot of people are very excited about the video sensor stuff, especially after 9/11, right? So the idea here is, for security, we would like to have lots of cameras, right? Lots of cameras looking at you. How many of you been to London where you saw?
Track you through the whole city.
Yeah, so we want to have London on steroids, right? We want to have.
On average, I think you get a picture of you gets taken about 400 times a day in London.
Yeah, so
all the CCTV camera systems.
So that's not enough. We want to have lots and lots of cameras where it watches everything.
What I understand is, what's the point of having everything on record if you're not going to look at it? Like the problem with the bombings they had in London, they had records of the guys doing 2 or 3 tries before they actually did it, running away from the stations and everything, a month and a half in advance. Nobody saw the videos. Nobody saw what they were doing.
No, so
time came and boom, and you're like.
So it's worse than that. So there's a faculty from City College London, right? He said what the British government don't want you to know is most of these cameras are so horribly out of tune that they're useless, right? So one of the things he said was, like, there are bird droppings, there are like rain-induced, the gunk, right? So if you look out the window, right, often somebody comes and cleans these windows, but those cameras are out there, right? So he said, even the best cameras that they have get all kind of issues, right? So he said most of the videos are useless because even if you look as a human being, you can't really make out. I mean, unless of course like the camera's right here and I'm looking at the stuff, right? And the real case you want is like a few pixels worth of somebody doing something. So even if you have somebody looking out, it's horrible. But as you pointed out, if you have a population of n, you really want somebody, n viewers who are looking at these stuff, right? Forgetting all those, people just want to build the case where they want to add lots of cameras, add lots of stuff, and
this doesn't make sense. People seem to think, oh, there's a camera system, it must be more secure, and then you're like, even in the buildings, you see they got 10 or 20 cameras around a building, for example, and you get one person looking at the cameras.
Oh no! So the future system is not one person. The future systems are computers looking at the stuff, right? So the recognition folks, which I don't want to sound whatever, right? So the recognition folks would finally can say, aha. So within the academia, we are trying to figure out a ways why we should exist so we can get money from some agency, right? So now so I don't mean it in a bad way, but that's the reality of it, right? So the recognition folks suddenly can say, aha, so now we can actually, there's a reason why we exist. We can, instead of having one human being per something, now we can do all this stuff automated, right? Yes, there are a lot of challenges, and there are a lot of reasons why it doesn't work, but essentially that's what you want to do. You want to have, in this classroom, let's say 200 cameras, right? And then you want to have all of them being automatically recognition going on. So ideally, right? Don't think it's Big Brother, but ideally, if you start get up, I want to know that you're trying to do something and do something to you, right? And be able to do this across the campus, so there'll be no crime or whatever, right? So the moment you decide to do something, we are watching you, we'll take action against you.
But don't casinos have just tons of cameras, but they don't watch them all? Some of them just don't work?
No, they're watching them.
They're watching them, oh, okay.
I have no...
Well, because I've also heard of other systems, like in Germany, they have, on the roads, they actually do have a speed limit. Or somewhere in Europe, they have a black box, and you don't know if there's a camera in it or not.
Oh.
And if you're speeding, it takes a picture of your license plate. But you don't know if there's,
Oh. But anyway, the systems we're going to look at for the next few lectures are actually they're looking at the stuff, right? So the one of the projects we're looking at, which is the next Thursday, is a project where they want to look at the entire Oregon coast, right? From I think it's 13,000 miles or some long, right? Have a camera across the whole thing. They're not looking at. They're trying to figure out how the oceans behave, how the tides come in and all those things. So they want to see the whole view for scientific purposes and stuff. So that's one of the projects. So we're going to look at a couple of projects, but I'm saying there's a lot of interest within the community on trying to figure out how to have lots of cameras and work at the stuff. I think Honeywell is looking at, on the Red Sea, they have one of the oil pipelines, which is pretty long. I think they have 10,000 cameras or something, going through areas of the country where most of the oil fields in unstable parts. So they want to be able to look at people. I don't know what they would do if they see somebody planting a bomb, but they want to do that, right? So that's the next phase of what we're gonna. Some of the papers we'll look at, right? So see you guys next Thursday from Seattle, and also see you at the. Huh?
Next Tuesday from Seattle?
Next Tuesday from Seattle. But see you also in the afternoon for Clara stuff.